I would like to now talk about evaluating expressions involving inverses. Recall that from an earlier topic we talked about what happens when you have the inverse of an inverse. So for example, on this one, find cosine of cosine inverse of 3.7. We talked about how you wanted to look at the outside function and find out what that outside function was telling you. It's telling you that because it's the original cosine, that the thing you want to find out is the value. We said that the cosine function and the cosine inverse function essentially canceled each other out, and then you were left with 3.7. We also talked about how you wanted to make sure that in this case, because 3.7 is a value, we want to ask ourselves, is 3.7 an okay value for cosine? Well, no, it's not, because we know that cosine of theta has got to lie in between 1 and negative 1, and 3.7 is not in this interval. And so in this particular case, what you want to do is you want to just write down that there's no solution. Okay, in problems we discussed earlier, there was a solution for some of those. And also remember that some of them you were looking for a value, some of them you were looking for an angle. Now, the difference here is that we're looking at inverses, but they're not necessarily functions that are inverses of themselves. So in other words, on the outside of this function you see cosecant, and on the inside of this function you see cotangent inverse. These are worked totally different than the problems before. First of all, those functions absolutely do not cancel each other out because they're not inverses of each other. Secondly, we're going to think about this in a different way. In this particular example, you see that your original function is on the outside. We're going to think about the entire inside expression as being an angle. So in other words, essentially, we're finding cosecant of an angle. Well, it turns out that I don't care what that angle is. I don't want to find it. I don't care about it. But what I would like to find out is, based on this information, can I figure out, in this case, cosecant we know is defined as r over x, can I figure out an r and an x for this particular situation? The inside function, being an inverse, actually is giving me this. Negative 1 over the square root of 3 is the value of cotangent. Okay. Cotangent, I know, is x over y. Well, in this situation, I could either have the negative with the 1 on the top, or I could have the negative with the 3 on the bottom. I'll go ahead and denote that out here to the side. I could have negative 1 over the square root of 3, or I could have 1 over negative square root of 3. And I'm not sure really which one of those two it is until I look at this a little bit closer. Let's draw a picture. Okay, the quadrant in which x is negative and y is positive is going to be quadrant 2. Let me go ahead and label these sides. So I have a negative 1, I have a positive square root of 3, and then I recognize this as a special triangle, and I can label the other side as 2. Okay, in the other situation, I have x is positive 1 and y is negative. That would happen in quadrant 4. So positive 1 and a negative square root of 3. The other side is still 2. Okay, it's a special angle. Now, what I have to consider is I have to consider that for this particular function, I'm talking about the inverse of cotangent on the inside, right here. And so for cotangent inverse, what were the restrictions on my angles? Well, my angles for cotangent inverse is anything between pi over 2 and negative pi over 2 and pi over 2, but not including those endpoints. So I'd be looking here to here, and I mean only rotating up and only rotating down. So this over here can't be a possibility. That being the case, then I know I'm considering the triangle here. So this is the correct picture, in other words. Okay, now, if that's the correct picture, keep in mind that what we want to find here is we want to find out what is the value of cosecant for this angle that I'm looking at. I don't care about the angle. In this particular problem, I know what the angle is, but I don't care about it. All I care about is, for this triangle in this picture, do I know an r and do I know an x? Absolutely. R is equal to 2, x is equal to 1. And so the value of this whole thing is 2. I'd like to look at another example. Find the tangent of sine inverse of negative 2 over 5. Okay, this is similar. In other words, what I'm wanting to do is I'm wanting to find the value of tangent. I can think of this whole inside thing as being theta. Okay, on here, the negative 2 over 5, that's the value for sine. So in other words, negative 2 over 5 would equal y over r. Let's draw a triangle, or several triangles if we need to. Okay, y is negative in which quadrants? We could do quadrant 3 or quadrant 4. Negative 2, the r is 5. Negative 2, the r is 5. Okay. From here, let me first think about restriction on sine inverse. The inside function here is sine inverse. And so I want to make sure which one of these two triangles I'm looking at. Okay, for sine inverse, theta must lie in between negative pi over 2 to pi over 2. So that means that I won't consider anything here or here, and this angle is actually rotated down. Now, once again, I don't care about the actual value of the angle here. Instead, I'm going to go back up and I'm going to remember, what am I looking for? I'm looking for tangent of an angle. Tangent of an angle is equal to y over x. So I need a y value and an x value for my picture. I already have a y value, so all I need to do is figure out what x is. Use your Pythagorean theorem. Alright, we don't know what x is. We do know that y is negative 2, and we do know that r is 5. Okay, solving this equation, we get x squared is equal to 21, and then when you take the square root, make sure you remember your plus and minus sign, depending on which quadrant you're located, will determine that sign. We're in quadrant 4, so the sign of x would be positive square root of 21. And we can go ahead and label that up above. Now, I have an x value, a y value, and an r value. That's all I need to evaluate my original question. What is y? Y is negative 2. What is x? The square root of 21. The final thing I need to do is rationalize my answer. So my final answer will end up being negative 2 square roots of 21 all over 21. This concludes my lesson on evaluating expressions involving inverses.